Okay, this lesson is on finding limits by factoring. And what we have here on both of these examples is we have a limit where x is approaching a number that if we plug the number into the function, we get a value that does not exist. We have a problem. So on this first one, and it's not that apparent at first, but if you were to plug a -4 in here, what you would get is 0 over 16 minus 16, which is also 0. So you get 0 over 0. And we know whenever we have 0 in our denominator, that's a problem. So we can't just plug in -4 and see where this is going. So one thing you can do on a lot of these rational functions is you can work with them a little bit, factor them, and then you're in a situation where you could plug this number in and figure out what the limit's going to be. So that's what we're going to do here. We are going to first simplify our function by factoring it, and then we're going to try plugging in the -4 for x and seeing if we can get a value. All right, so what we're going to do is start with the top. The top, we have 7x plus 28. The only way to factor that's with the greatest common factor. And 7 and 28 both have a factor of 7. So I'm going to pull a 7 out front. When we factor out a 7, we're going to be left with x plus 4. So I just pulled the greatest common factor out of each of these terms, put it in front of a parentheses, and then we were left with x plus 4. On the bottom, that's a trinomial. We have x squared plus x minus 12. We're going to factor that into two parentheses. We have x and x. I need two numbers that multiply to give me -12, add to give me a +1. That's going to be a -3 and a +4. And what happens here is these x plus 4's cancel each other out. And that simplifies our expression quite a bit, and we get 7 over x minus 3. So in a sense, these two things are equivalent, but when we have this simplified version, it doesn't give us the same problem with -4. So in a way, it's not complete, but what it can do is it can tell us what our limit is. So what we're going to do is take this -4 and plug it into the simplified version. So we have 7 over -4 minus 3. So we just plug that in for x. And when we work that out, we get 7 over -7, which is -1. So we know the limit as x approaches -4 of this function is -1. So let's do one more here. So same idea. We have x is approaching -2 this time. If you were to plug a -2 in for x, you would get a 0 on the bottom. So that gives us a problem. But again, if we can factor it, we might be able to get rid of that problem and get something we can work with. So on top, the first thing I see is I have an x cubed, which isn't very fun for factoring. But I also see that all three of these terms have an x. So what I can do is I can factor out an x. And what that's going to leave me with is x squared plus 3x plus 2, which is much nicer to work with now. And then I have x plus 2 on the bottom. So now I can factor what's in that parentheses. So I'm going to have x and x. I need two numbers that multiply to give me 2, add to give me 3. Really the only thing I have to choose from is 2 and 1. So we have x plus 2 and x plus 1. My denominator is x plus 2. And so those x plus 2's cancel each other out. And what I'm left with is x times x plus 1. And if you want to simplify that by distributing, you can just make that x squared plus x. But I don't have a denominator. So -2 is no longer going to give me a problem. So now what I can do is plug in the -2. So that's going to give me -2 squared plus -2. Which is going to give me 4 minus 2, or plus -2, which is just going to be 2. So my limit as x approaches -2 of this function is going to be 2. So if you were to graph these functions, what would happen is in the case of this one, you'd have like a hole at where x is equal to -2. And on the previous one, you'd have a little hole where x is equal to -4, because they have these restrictions to their domain. But if you factor it, you can still get an idea of what the function would look like and where it is going as it approaches this point, even though it can never actually get there. So if you factor it and then plug in the number, that gives us another way that we can find the limits of these functions.